Okay, sixth graders, in lesson 5.3 we're going to talk about adding and subtracting mixed numbers. So some wholes and some fractions. Yesterday we talked about adding fractions, and when you're adding fractions you have to make sure that the pieces are the same size when you add them or subtract them. Right? So how do you make the pieces the same size? The bottom number, the denominator, to a multiple of both numbers. A common multiple, we call it a common denominator. So that all of the pieces are the same size, and then we can add and subtract. So to add mixed numbers, you're first going to add the whole numbers, and then add the fractions. Okay? So, for example, if you have 2 3/4, you have 2 wholes, and then 3/4 of another one. 3 pieces that are cut into fourths. Okay? And then you have 3 more wholes, and you have 1/2 of another one. So, how many wholes do you have? Class? How many wholes do you have?
5.
5 wholes. 3 plus 2 is 5. Okay? Now, add the fractions. 3/4 plus 1/2. You can't just add the total pieces yet because the pieces are not the same size. So we have to convert 1/2 to what? 2/4. Multiply both by 2, right? Or in our drawing, if we just cut this in half, now we have 2/4. So now we have fractions, and all the pieces are the same size. They're all cut into fourths. So add the pieces. This equals 5/4. And what we realize is that if we have 5/4, we can make another whole. 5/4 is really 1 with 1/4 left over. Right? So you have to add this 1 whole to the 5. We add this. This is what we got from the pieces. And that makes 6 1/4. Okay? Questions on this? You have a question, Raiden?
Why don't we just do the fractions first?
Add the fractions first?
Yeah.
You could add the fractions first.
That's how I did it. But then you could just put 1 on 1 to the 2 or the 3, and then that would make 6. And then you could just go right away to 6.
Well, either way, you're going to get either 1 1/4 plus 5, or 5 plus 1 1/4,
So
right?
that's 6.
Yes.
Wait, does this have anything to do with we're doing the for 2 3/4? You said, are we doing the 2 times 4 and then
Yeah.
plus 3? Are we doing that?
No, we're not doing that. We're not converting this to a top-heavy fraction. But sometimes when you add all the pieces, you end up with a top-heavy fraction. Right? Because we have 5 pieces. 3 pieces plus 2 pieces is 5 pieces. Or 3/4 plus 2/4 is 5/4. So then we have enough pieces to make another whole. Right? And then there's 1 piece left over.
Wait, but
We have 1/4 left over.
why is 5/4? That's like is the denominator supposed to be bigger though? Or no?
No, the denominator tells us how big the pieces are. These pieces are cut into fourths.
5/4. Well, how is that possible to add 5? If there's
5 pieces. There's 5 pieces. and they're all the same size. They're all fourths of the whole.
So there's 4 triangles and then there's 5 slices?
Right.
What? That makes no sense.
Well, Matt, you're exactly right. If you have 5 slices of pizza, but a whole pizza is 4 slices, so you have a pizza and you cut it into 4 pieces,
But then
and if you have 5 slices, that means that you can take one of those slices and put it to make a whole pizza, and then you'll still have 1 left over.
But, like, where would you put the other 5 piece? Then it would be even. All it would be the same if you had a 5 slice one. Because
You're not asking the right question. You're not asking the right question. Where would you put the 5 pieces?
where would you put the 5th slice even? That's what I meant.
You can't put it anywhere. That's why it's 1/4 left over. This is a fourth of a pizza. This equals 1/4.
Wait, so 1/4 of a pizza because it's 1 out of 4 because 1 slice out of 4 pizza. Is the 5 left over so we put in 1 there?
The 5 isn't left over. The 5 is the total number of pieces. 1, 2, 3, 4, 5.
But isn't that weird if it like comes in a box and there's 4 slices and then 1 like just randomly in a random place?
We're not talking about we ordered 5/4 of a pizza.
Is that even possible?
I don't know. That's a totally different subject now. Okay? Do you understand having 5/4 means you actually have 1 whole and 1 more piece?
Yeah.
Okay, good. Stop there then, so you don't confuse yourself.
I know, but
Okay.
it could be an example of.
No, stop. Okay, you're just gonna confuse yourself if you keep going. Stick with what you know. Subtraction. Okay? When you're subtracting, you have to make sure that you have enough pieces before you subtract. Okay? So, when you're given a mixed number subtraction problem, copy this one down. Copy this one down. 4 1/2 minus 2 1/5. Okay? Now, since we're going to be taking away pieces from what we have, this is what we have. Oops. This is what we have, and this is what we're taking away. You have to make sure you have enough before you can take away. So we have to change the fractions so that we have common multiples in the denominator. What's the common multiple we should use for 2 and 5? Abby? 10. How many tenths is 1/2? Oops, let's do this. How many tenths is 1/2? 5 tenths. We multiply both by 5. So this is 4 and 5 tenths. And how many tenths is 1/5? Good, 2 tenths. So we're taking away 2 and 2 tenths. Right? Any questions so far? Then we know we have enough pieces. We have 5 and we need to take away 2. 5 minus 2 is, just show me. 5 minus 2 is? 3. Good. Half of you showed me. And 4 wholes, take away 2 is 2 left over. So 2 and 3 tenths. Okay?
I feel like this is easy.
Now, sometimes you won't have enough pieces. If we change this problem so that we were taking away 4/5 How does that change the problem? Convert it to tenths again. So we had 4 and 5 tenths, right? Nod your head if you're with me. Okay. Minus 2 and what? How many tenths will we need to take away? No, 2 times 4 is, we're changing the problem, 8 tenths. Okay, we're converting it because I changed the number of pieces we're taking away. We need to take away 8 tenths, but we only have 5 tenths. So now we have to make more tenths. We have to cut one of the holes into tenths. 10 out of 10. Okay? So we have to draw a line through the 4 and write a 3. So we're going to take one of the holes away. And we're going to add 10 pieces because this is in tenths. We're going to add 10 pieces to the ones we already have. Okay? How do you know to add 10? How do you know to add 10? Why not you add 5? Or why don't you add a different number, Jack? Because the denominator is a 10. So we're going to add 10 tenths, or 10 pieces that are cut into tenths. So now we have 15 tenths. Okay? Let me write this 3 right here. So we're changing 4 and 5 tenths to 3 and 15 tenths, right? Right? Okay. Matt?
Well, because you can't do 5 minus 8, so we have to have a bigger number, I'm guessing.
Exactly. We have to have more pieces. Now we can subtract, right? Now we have enough pieces. We can take away 8. That leaves 7. And now subtract the holes from the remaining holes.
1 and 7 tenths.
1 and 7 tenths. Okay? So, let's review. First, we converted it to a number with a common denominator. Converted it to tenths, and then we realized that we can't take away 8 pieces because we only have 5 pieces. So you cut up one of the holes. Now we have 3 left. And add 10 pieces, because that's our denominator. Add 10 pieces to the ones we already have. We have 5, plus 10 is 15. And then we can take away 8. And then finish the problem. Any questions on that? What if we got to an answer and we could divide both of them by 2, or it wasn't in simplest form? Would we have to put it in simplest form? Would we have to put them in simplest form? Yeah. You got to make sure that you reduce the fraction, if you can, to simplest form. Okay? Any questions? All right.